Hello, you're welcome to my channel. In this video, we're going to be solving this exponential equation which says 3 raised to the power of 2 plus x plus 3 raised to the power of 2 minus x is equal to 82. Now let's start off by using one of the laws of indices, which states that if you have, say, x raised to the power of a times x raised to the power of b. Now because they have the same base, you can resolve this by writing the common base, which is x, and then adding the exponent a plus b. Now what we want to do now is I want to take it from this form as we have here to this, and we'll do the same thing to this second term here, which is, but there's a minus there. In this case, we are going to be using the division law of indices, which is if you have x raised to the power a divided by x raised to the power b, this is equal to x raised to the power a minus b. So these are the laws of indices that we're going to be applying here so that we can simplify and then take it off from there. So let's get started. Now it's going to be 3 raised to the power of 2 times 3 raised to the power x, okay, then plus here 3 raised to the power 2 divided, like I explained earlier, by 3 raised to the power what? X. If you apply the law of indices, this we have 2 minus x, here you have 2 plus x. Okay, now this is equal to 82. The next thing I will do, what is 3 raised to the power 2? It is 9. So I will write 9 times 3 raised to the power x plus, here this is still 9. Then now this division, so I'm going to put over, then this 3 raised to the power x. And this right here is equal to 82. 82. So what I will do next is to say let p be equal to 3 raised to the power x. The reason why I am replacing 3 raised to the power x for p is because I want to make the equation simplified. If you have exponents, as we have in this equation, it makes it more difficult to find the value of the unknown. So I'm going to replace 3 raised to the power x for p to make the equation simple. So it's going to be 9p, because I just said let p be equal to 3 raised to the power x. So here it's going to be 9p plus 9 over p, because this is 3 raised to the power x, which is now p, and this is equal to what? 82. So what I have here is a simple equation. We don't want this fraction. We want it to be without a fraction. So what I will do is to multiply every single term, both on the left hand side and on the right hand side, by p, so as to get rid of the p in the denominator. So it's going to be 9p times p plus 9 over p times p is equal to 82 times p. All right, p here cancels p, which is my intention. 9p times p is 9p squared, then you have plus 9, and this is equal to 82p. So let's transpose 82p to the left hand side, so that I will have all the terms on one side. That will be 9p squared. You can just rearrange it as you do in quadratic equations. It's going to be minus 82p and then plus the constant term 9, all is equal to 0. So I'm going to factorize so that I can get the value of p in this equation. This is a quadratic equation. We'll think of 2 factors such that when we multiply, we are going to get, let's multiply 9 and 9p squared. You're going to get what? 81p squared. So think of 2 factors. When you multiply these 2 factors, you will get 81p squared. And when you add these 2 factors, you are going to get what? This middle term, which is negative 82p. What should they be? Minus 81p and minus p. If you multiply this, you will get 81p squared. Or if you add these two, minus 81p and negative p, if added, you get negative 82p, which is what I have in this middle term here. Okay, so that makes it much easier for us. That's going to be 9p squared. I'm going to replace negative 82p for these 2 factors that we earlier brought out. So it's going to be minus 81p, then minus p, then plus 9 here, and is equal to 0. Okay, so let's move on. Now I'm going to factorize the first 2 terms and then the second 2 terms. The first 2 terms and the second 2 terms. So look at these first 2 terms. What is common? 9p is common. So let's factor that out. 9p goes into 9p squared. you are just going to have p and minus 9p goes into negativity 1p. You have negative what? 9. So negative 9. Okay, and let's look at these last two terms. What is common? You might say nothing is common, but negative 1 is common, or let's say 1, but we're going to change plus to minus. So when you open this bracket, negative 1 into negative p, you will give you what? P. Yeah. And negative 1 into plus 9 will give you what? Negative 9. Close the bracket, and this is equal to 0. One more factorization, because we have a common term. If you look at this term and this one, what do you think is common? P minus 9. That's right. So p minus 9 factored out again. What you have now is 9p here and negative 1 here, and all is equal to 0. Next thing is to bring in the zero product rule. When you have two factors multiplied together giving you 0, it means that either one of the factors is 0, or the two factors are 0. So this means that p minus 9 is equal to 0, or 9p minus 1 is equal to 0. So let's transpose negative 9 to the right hand side. You have 9, or transpose negative 1 to the right hand side, you are going to have is equal to 1. But we still need to divide both sides by 9 here. And then you have p is equal to 9 from here, or this cancels this. P is equal to what? 1 over 9. Now recall, since we already have the values of p is 9 or p is 1 over 9, recall that we set p to be equal to 3 raised to the power x. Since we are looking for the value of x and not p, we need to bring back 3 raised to the power x. So I will say when p is equal to 9 from here, what is going to be x? So I'm going to replace p for 3 raised to the power x in this equation. So it's going to be 3 raised to the power x is equal to 9. Take it a step further, you have 3 raised to the power x is equal to 9 can be expressed as 3 raised to the power of 2. Okay, now they have a common base, so we're going to equate the exponent. It means that x is equal to 2. First solution. Let's look at the second solution. So I'm going to say when p is equal to, what's the second value of p? 1 over 9. Again, we still have that 3 raised to the power x is equal to what? 1 over 9. Now 1 over 9 can be expressed as 9 raised to the power of negative 1 from one of the laws of indices. So they still do not have a common base, so it's going to be 3 raised to the power of 2. 3 raised to the power of 2 is 9, but we still have the negative 1 exponent. So these two exponents are going to multiply together, and you are going to have this 3 raised to the power 2 times negative 1 is negative 2. So they have a common base. What are we supposed to do? We're going to equate the exponent. So x will be equal to what? Negative 2. Now we have the two values of x. X is equal to negative 2. X is equal to what? 2, as we earlier got. So we will conclude by saying, therefore, x is equal to negative 2 or 2. Now let's quickly test it into the equation, and let's see if these two values of x will satisfy the equation. So let's rewrite the equation again in the original form. 3 raised to the power of 2 plus x plus 3 raised to the power of 2 minus x is equal to 82. So let's start with negative 2 here. That's going to be 3 raised to the power of 2 plus negative 2. Remember, x is negative 2 when we are using this one. And then plus 3 raised to the power of 2. X is negative 2, so minus negative 2. Let's see if it will give us 82. Let's do that. What do we have here? 2 plus negative 2 is going to be 0. So you have 3 raised to the power of 0 plus, what about this? This is 3 raised to the power of negative, negative. We change to plus, so you have 2 plus 2. Okay. 3 raised to the power of 0 is 1. And then this is 3 raised to the power of what? 4. What is 3 raised to the power of 4? That is 81. When you add 1 to 81, you get what? 82, as we have on the right hand side. So we have tested that x is equal to negative 2 satisfy the equation. So let's look at the second solution that we had. which is x is equal to 2. So we're still going to plug it into the equation. Let me rewrite the equation again. 3 raised to power 2, x is 2, so plus 2, and then plus 3 raised to power 2 minus, what is x? X is 2, so replace that there. And then you have 3 raised to power 2 plus 2, that's 4. Then plus 3 raised to power 2 minus 2 is what? 0. So what do you have? 3 raised to power 4 again is 81. And 3 raised to power 0 is what? 1. When you add these two numbers, you get what? 82, as we have on the right hand side. So yes, the two values of x that will satisfy this equation is either x is equal to 2 or x is equal to negative 2. I hope you enjoyed this video. If you do, kindly subscribe for more content like this and share this video to your friends and family. I'm going to see you in the next one. It's bye for now.